My name is Sarah Elger, and I'm the Director of Process and Innovation at Enviromix. Thank you so much for joining us today for our webinar, which is featuring Director of Sales Mark Gehring and is entitled The Gold Standard for Mixing: Versatile, Reliable, and Low Maintenance. Before we begin, I just want to cover a couple of housekeeping items. We all have our cameras off, not because the leprechaun got the best of Mark, but because we want to ensure the best viewing experience for you. We have a couple of videos to show. Additionally, you're all muted now, and you will be for the duration of the presentation. So if you have any questions that you would like us to answer, please just use the Q&A feature at the bottom of your screen, not the chat, but the Q&A feature that's at the bottom of your screen. You can send any questions that you might have. And we'll answer those during a short question and answer period that's at the very end of the presentation, assuming we have time. If we don't get your question, though, during the 40 to 45 minutes that we're planning for today, then we will be sure to answer each of your questions via email after the presentation. Lots of people always want to know, we will be emailing certificates of attendance for all of you who attend the webinar live. So you will get those within the next day. And with that, I think we're ready to get going, and I'm going to hand it over to Mark.
Thank you, Sarah. Hello, everyone, and welcome to today's webinar on the gold standard for mixing: versatile, reliable, and low maintenance. My name is Mark Gehring. I'm Director of Regional Sales here at Enviromix. It's great to have you all here with us today. Let's jump into the agenda for today's webinar. First, we'll kick things off with a case study from North Carolina. Then we'll take a step back to explain how Biomix works, what's included in a compressed gas mixing system from a scope standpoint. After that, we'll go into another case study from a small plant in Utah and specifically look at how channel mixing is related directly to biological phosphorus removal. Then we'll talk about applications and specifics from mixing before we finish off with a case study from Exeter, New Hampshire, a plant that utilizes Biomix widely in various swing zones and other applications. And of course, there will definitely be time for Q&A at the end. And as Sarah said, please feel free to submit those questions throughout the presentation using the Q&A feature. Our first case study is for the Sigwasa wastewater treatment plant located in Butner, North Carolina, which is in the Raleigh-Durham area. The Sigwasa wastewater treatment plant installed Biomix compressed gas mixing in 2015, and the reason for the upgrade was twofold. One, due to tighter effluent permit requirements, they upgraded to a 5-stage Bardenfo process, requiring the addition of post-anoxic zones that they carved out of their existing oxidation ditches. The ditches were also converted to plug flow aeration basins in the process. Second, the plant had an aging jet mixing system that was in need of replacement. Ultimately, they ended up choosing Biomix for a total of 8 tanks, as shown on this Google Earth image. And for added flexibility, they kept the aeration equipment in the post-anoxic zones so they can utilize to choose that to operate as either aerobic or anoxic. Sigwasa realized 75% energy savings with their upgrade to compressed gas mixing, while also reducing the number of maintenance touch points required. The highlighted red circles show where jets or mechanical mixers would have been required. 10 locations with 10 pieces of rotating equipment to maintain individually. With Biomix, their single maintenance point is located at the compressors inside a building. As an added benefit, they have a standby compressor that rotates with the duty compressor on a weekly basis, providing 100% redundancy for the mixing system. 6 years later, in 2021, the plant took a step toward reducing their chemical addition with an upgrade to Biomix DC in their anaerobic selector. By changing their mixing regime, they increased their anaerobic mass fraction, created a fermentation base blanket, and increased VFA production. The result is more consistent biological phosphorus removal, which has allowed them to reduce their chemical dosing. We have a short testimonial from their superintendent who says, "We like the Enviromix system, and obviously we've gotten positive results." The positive results the superintendent is referring to can be seen visually on this graph with 18 months of data. In orange, we show influent total phosphorus, which bounces around day to day and week to week. And the effluent total phosphorus, shown in blue, is almost always lower than 1 milligram per liter because they are adding chemicals. In November of 2021, we implemented Biomix DC, represented by the black dotted line. You can see that since then, the plant has been able to stabilize their effluent phosphorus and eliminate the bumps. This was one of a few test sites for Biomix DC, which won the 2022 Innovative Technology Award presented at WEFTEC. The general concept is that Biomix DC creates a fermentation blanket during an unmixed period, and then resuspends the solids during a mixing period. But because of how compressed gas mixing works, Biomix DC provides gentle intermittent pulses throughout the deep cycle to transport VFAs out of the blanket without disrupting the fermentation and hydrolysis. Since this installation, we have well-documented results from multiple facilities realizing increased VFA production, increased phosphorus release in the anaerobic zones, and improved effluent phosphorus quality. We presented a prior webinar on Biomix DC, and we also have a 4-part video series about enhanced biological phosphorus removal. All of those recordings can be found on YouTube or by following links through our website if you would like to learn more. Since versatility was included in the title of this presentation, let's look at how Sigwasa did just that. They were able to mix 8 zones with a centralized compressor system, saving energy and eliminating 9 additional pieces of equipment to maintain. They utilized their existing Biomix equipment, and with a program upgrade alone, they improved their biological phosphorus removal. They also integrated Biomix with diffused aeration, giving them flexible control over their post-anoxic zone. Let's dig into that a little bit more. Just below the water surface in this photo, you can see the aeration headers that run parallel to the length of the tank. And if you look closely, you can see the Biomix headers running perpendicular to that. This arrangement allows them to have a versatile reactor. In colder months, they can make this volume aerobic to ensure they are nitrifying completely. And if they need to reduce their total nitrogen or reduce their recycle pumping rate, this volume can be used as a second anoxic zone. This gives them a lot of operational flexibility and would be challenging to do with other mixing technologies. Most other mixing equipment cannot be operated simultaneously with diffused aeration, which can destroy the mechanical mixing equipment through cavitation. But with this sort of arrangement, they have quite a lot of versatility and can operate both aeration and mixing simultaneously. Hopefully that case study gave you some sense of about the benefits of Biomix. But let's take a step back now and go through some of the fundamentals, specifically how compressed gas mixing works. Biomix works by releasing air through engineered nozzles that are fixed to the floor of the tank. Sequential bursts of compressed air provide mixing to the entire basin from the bottom up, with the large bubbles expanding as they rise to completely mix the tank contents. This animation is accelerated slightly to illustrate the mixing regime. Most mixing systems are typically fired from each location every 20 or 30 seconds, about 2 to 3 times per minute. And there is built-in flexibility in the mixing parameters. And I'll give two examples. The operator can change the mixing frequency. Instead of firing every 20 seconds, the operator could choose 15 seconds to get more agitation. They can also change the duration. Instead of a half a second burst, a large bubble could be released with a 1 second burst. These and other parameters all provide the ability to increase or decrease the mixing intensity to suit process requirements. At first glance, it's not uncommon to see biomix and draw comparisons with coarse bubble aeration. But because biomix produces a much larger bubble, surface contact is minimized, and because the bubbles are fired intermittently, biomix uses 95% less air volume and therefore doesn't transfer oxygen. This is why it is widely used to mix anaerobic and anoxic environments, as we highlighted previously in our first case study. The portion of the equipment that is shown here is all included in the typical scope of supply. Stainless steel nozzle headers and valve modules located immediately adjacent or a short run away from the tank. Allow me to zoom out and see the rest of the system. Biomix starts with a centralized compressor that can be used for multiple applications. The compressor, which uses ambient air, modulates to maintain system pressure while conserving energy when demand is low. Charged by the compressor, the receiver tank supplies compressed air to the valve module. This controls the mixing intensity and releases the bottled up air in high pressure, high velocity, timed bursts through engineered nozzles across the floor of the tank. Large volumes of gas generate an upwelling motion and create large circulatory currents, suspending solids and maintaining a completely mixed environment. On the surface, you can see the convergence of these currents and the uniform distribution of energy showing the entire volume is mixed. That was an animation of the process. I also wanted to share an actual video of the system working in a clean water test at a plant in New York. In this application, the biomix nozzles of the floor, on the floor of the tank, integrate easily with the aeration. And just like the post-anoxic zones at the SIG-WASA plant, this allows the plant to mix, aerate, or do both simultaneously. In many cases, aeration equipment is sized to provide enough air for both oxygen demand and for mixing energy. For fine bubble aeration, the requirement for mixing energy is 0.12 SCFM per square foot of tank area. This threshold can be limiting when trying to turn down the aeration, which is where supplemental mixing comes in. In fact, decoupling aeration and mixing provides a big feature of biomix, offering flexibility in a number of applications, but more on that later. The mixing requirement for sludge holding tanks and aerobic digesters is often much higher, meaning the energy savings potential with compressed gas mixing is that much greater. In summary, I hope you have learned how biomix accomplishes the gold standard for mixing by accomplishing versatile and reliable mixing, requiring low maintenance, all the while saving significant energy. Of note, Enviromix scope is BABA compliant. Sarah?
Thanks, Mark. This brings us to our first audience question. How does biomix ensure negligible oxygen transfer while mixing efficiently? Is it short duration bursts? Is it large bubble size? Is it high pressure, low volume air? Or is it all of the above? I'm going to give everyone just a couple of moments to take a vote and pick one of the choices, and then we'll review the answers together in just one moment. All right. Well, I guess I can't fool any of you. It looks like many of you selected all of the above, which is the correct answer. Congrats to those of you that got it right.
Thank you, Sarah. Now we're going to shift gears to talk about our second case study, Wellington, Utah, which is a town of about 1,700 people located on the Price River. Diffused aeration is a very common technology in many channels across wastewater treatment plants. It's a great solution for keeping solids suspended because it provides bottom-up mixing and is suitable for long and narrow tanks. Overall, it is a great solution for 20th century plants where the aeration can assist in delivering oxygen and help break down carbon. However, with biological nutrient removal plants, consuming carbon or adding dissolved oxygen in channels detracts from the biological nutrient removal process. Whether it's preserving readily biodegradable carbon for biological phosphorus removal or for denitrification, that carbon is better utilized without oxygen, and that is a major driver for selecting compressed gas mixing for channels. In 2022, the Price River Wastewater Treatment Plant replaced their existing diffused aeration with biomix in the influent channel with the goal of maintaining an anaerobic environment, and they also added biomix to their two anaerobic basins. At 2.2 million gallons per day, this is a smaller plant with less tanks to mix than our previous case study, but they are still able to tap into the versatility biomix offers. First, given the geometry of one long narrow tank and two rectangular tanks, any alternatives would have required different equipment for each application. Biomix allows them to use the same compressed air source for both. Second, and one unique aspect of this project, the plant had an existing compressed air system that Enviromix was able to utilize for mixing, meaning they didn't have to buy new compressors for the mixing system. We've done this in the past on a number of projects, and as long as we can get clean and dry air from an existing compressor, we can utilize that compressed air and provide a very economical solution. Third, the maintenance for the system is very low. More on that on the next slide. They already maintain their compressor, and the rest of the biomix system doesn't require any regular maintenance because the nozzles and in-tank equipment are maintenance-free, non-clogging, and self-cleaning. Here is something the plant superintendent Blaine said about the system. I like the fact there are no mechanical or electrical parts underwater. That's part of the reason I wanted to go this route versus some other kind of mechanical mixing. And I like the fact that it's pretty much all stainless steel, so there's not much opportunity for corrosion. Without underwater moving parts and clog-free stainless steel wetted components, that leaves the only maintenance required, which can be done conveniently within a climate-controlled building. The simplicity of the system is something we hear often. No operator wants to be taking mixers out of a tank when it's 100 degrees in the peak of summer or 0 degrees in the bleak, dark winter months. I mentioned that this plant was targeting anaerobic environments in both the influent channel and the anaerobic selector. So let's dig into that a bit further. To test this, we shipped our mobile ORP testing unit out to Utah to get some live data. Generally speaking, anything that is above plus 50 millivolts can be considered aerobic, and below that to about minus 200 could be considered anoxic, and below 200 millivolts is anaerobic. From this chart, you'll notice that starting back in March and consistently during the entire testing period, we observed a robust anaerobic environment, all the while being mixed with compressed gas mixing. Here we're showing ORP consistently down near minus 400 millivolts and even below that, down to minus 450 toward the end of the testing period. As anticipated, we confirmed deeply anaerobic conditions. We have repeated this test at numerous other plants, and it is usually a sign that the conditions are right for biological phosphorus removal. Then we asked plant staff to move the ORP probe to the influent channel. And remember, they replaced their aeration equipment with the compressed gas mixing, and it's operating 24 hours a day, providing a burst of compressed air every 20 to 30 seconds without oxygen transfer. And in this case, again, we see that the ORP is consistently low and anaerobic for several weeks. In conversation with other operators using other technologies such as diffused air, we have heard that sometimes they need to turn down the air supply to their channels or stop mixing altogether in order to reduce the DO and ORP, something that is not a concern with Biomix. Surprise, another question. Sarah, please take it away.
Thanks, Mark. This next question is around applications. So in which of the following applications can Biomix be effectively utilized? And you can select all that apply. Is it tanks up to 30 feet in depth? Is it applications with solids concentrations up to 8%? Is it tanks with obstructions? And or is it tanks of unusual shapes or with sloped floors? I'll give you all a few moments to think about that answer and reply, and then we will share the results in just a moment. All right, here we go. All right, I see a mixed bag here, and it seems like you all kind of caught on from our last question, and the majority of you selected many, if not all of the answers, which is correct. We offer a lot of versatility and flexibility when reliable mixing is required, and Mark's going to talk a little bit more about some additional applications.
Thanks, Sarah. So far, we have talked about B&R mixing and channels, but I'd be remiss if to give a presentation on the versatility of compressed gas mixing without discussing the other applications where Biomix is applied. It is really great to see our customers appreciate the value of Biomix, including appreciation by this customer in Colorado. Here I will focus on 3 applications that demonstrate other ways to unlock versatility. In EQ tanks, Biomix is far less energy intensive than aeration and can be operated when the liquid level in the tank is variable. In sludge tanks, Biomix headers can conform to the cone bottom shape of the tank, mixing the entire volume without dead zones. This allows plants to unlock the full volume of their cone bottom instead of filling them with concrete or losing that volume to accumulated solids. In channels, Biomix is far less energy intensive and can be installed with different configurations. In 2018, a plant in Garland, Texas was unable to take their mixed liquor channel out of service for installation. The engineers at Enviromix designed a system for wet installation of the nozzle system while the channel remained in continuous operation. Enviromix offers unparalleled flexibility to suit unique customer needs. A typical wastewater treatment plant has multiple applications requiring mixing. And we have highlighted a snapshot here, all of which are applications Enviromix has successfully mixed. I've alluded to this earlier, but end users can get the most bang for their buck when mixing multiple applications with a single compressor system. Whether it is channels and BNR tanks or EQ tanks and sludge holding tanks, there is a great deal of benefit to be gained when sharing a compressor, receiver tanks, and control system. And we've seen a pretty rapid adoption of compressed gas mixing, essentially the foundational backbone of Enviromix. In some cases, end users have seen the benefits firsthand and expanded or upgraded their mixing system to include more features and process control. All of these dots on the map represent plants where Enviromix has provided a mixing system. For many of these dots, we have also provided higher order process solution. Thanks to the deep process engineering expertise of Enviromix, we can deliver treatment performance, not just a mixing solution. To cover a few more applications and to finish off our webinar today, we will now introduce the Exeter Wastewater Treatment Facility in New Hampshire. The Exeter, New Hampshire wastewater treatment plant went through an upgrade in 2017, in which they looked to provide mixing and aeration system for their first stage anoxic, anoxic swing, aeration, second stage anoxic, and sludge holding tanks. This facility at 4.5 MGD was designed with 2 trains for redundancy, and due to the number of small tanks requiring mixing, compressed gas mixing was selected in order to minimize the number of mixers and to save on the overall cost of ownership. They upgraded to a 4-stage Bardenfo process in order to achieve their new nitrogen removal requirements, and they were able to implement a very flexible process that swings between aerobic or anoxic environments, both on the front end and back end of the plug flow system. This is a very nice photo overlooking the entire plant, but if you look at the rendering on this slide, you'll see that there are 6 different zones in each aeration train, and then 2 trains total, as well as 2 sludge storage tanks, all utilizing biomix. So how did this plant unlock the versatility of compressed gas mixing? Well, certainly they benefited from an economy of scale. They can have separate zones, not requiring individual mechanical mixers. And again, they have a single compressor for convenient maintenance. Again, all these dots represent the maintenance touch points that would have been required with an alternative mixing technology. They also have 2 aerated sludge holding tanks where they can choose to aerate or mix. Most plants with this type of arrangement prefer to add air only as needed to keep the sludge from going septic, but most of the time they can just keep it mixed, and they can also mix while desludging to achieve a consistent solids concentration to the sludge processing system. Decoupling aeration and mixing not only helps save energy, but also provides a tool for greater optimization across a number of applications. They also have versatility in how they operate their aeration zones. They have one swing zone at the front that allows them to expand their first anoxic zone, and 2 swing zones at the back that allow them to operate aerobic or anoxic environments. And further, they have a mixing system at the end of their aeration zone that allows them to provide mixing when that zone is mixing limited. And what I mean by that is they have a DO aeration controller that turns down the airflow. But when there's not enough air to provide mixing, Biomix is available to provide complete mixing to that zone and a tighter DO control strategy. Having the ability to decouple aeration and mixing is especially beneficial to plants that are underloaded. Exeter was upgraded in 2017, and the use of compressed gas mixing to combat mixing limited conditions was also implemented at other plants. The issue of plants being underloaded kept presenting itself, and in 2022, Enviromix launched FlexZone Adaptive Process Volume to help provide plants the operational flexibility to match operations to current flow conditions, especially when designed for higher flow and loading of 20 or 30 years in the future. FlexZone consists of biomix and diffused aeration in one or more subzones, working together to achieve treatment objectives. It works by automatically enabling or disabling aeration in these subzones based on actual influent loading to the plant. By aligning aeration grids and biomix, the system can scale up or down based on operator inputs and automatic instrumentation feedback, without baffle walls between each subzone. Each subzone can mix, aerate, or do both simultaneously, which is what we call synchromix. By decoupling aeration and mixing, the process can instead be dynamically controlled using instrumentation feedback. FlexZone is suitable for both new plants and existing facilities. By flexing these volumes, FlexZone produces energy efficiency benefits, but also produces improved treatment with tighter control over key process indicators. We offer a webinar series on our website providing more information on our FlexZone process. So with that, I wanted to wrap up and remind everyone that this presentation today was primarily focused on biomix compressed gas mixing as the gold standard for mixing. However, FlexZone being one of our process technologies, we also offer a large family of products all centered around mixing as the core of our technology, with more features and process solutions growing out from there. In the past several years, we've expanded our product portfolio to include process solutions for conventional activated sludge, nutrient removal, inline fermentation, RAS fermentation, aerobic digester processes, and more. At Enviromix, when we talk about wastewater treatment, we are looking to provide holistic solutions for optimized treatment, in addition to being a great mixing technology. If you want to learn more about any of these products or applications, please check out our website with dozens of brochures, case studies, videos, and more. And definitely feel free to reach out to any of us directly, myself included.
Thanks, Mark. I am here to help facilitate some Q&A. We have a couple of questions that are already coming in and have come in through the presentation. I'll just read those aloud to you, excuse me. And then as you keep getting questions, anyone in the audience, please feel free to continue sending them in. Mark, one of the first questions I have here is, how do you keep solids from getting into the air header when there is no airflow?
Yeah, that's a good question. We operate the system with an exercise mode that periodically, if the tank is offline for whatever duration of time, can actually bump the tank, as we call it, and thereby keep the system exercised and move material that could have accumulated into the system out. But more importantly, we utilize a press fit piping and header arrangement technology that precludes leakage and material getting into the system in the first place.
Another question I have is, it says, do the diffusers have to be cleaned every year? But I'm thinking that they're talking about the nozzles in our system.
Yeah, good question. I would presume that means the diffused aeration system. Yeah, those would follow the manufacturer recommendations, periodically take the system down, check for any damage or leakage, and a gentle cleaning is usually all that's required for those. It's a good question.
This is a good one. Please clarify if the same air system can handle tanks with different water levels.
Yeah, again, here I would presume we're talking about the compressed gas mixing system biomix.
Yep.
And the answer is yes, absolutely it can. And the reason it can do this is we are releasing air to a common header with a number of nozzles on it at one at a time. And that header could be at a different water level than others in the same system. So the fact that you have different water levels and thereby different pressures on a common system, since the air is only being released from one header or one valve at a time, thereby you can operate this system at different water levels. It's a good question, especially as we run into conical bottom tanks where we array the headers at various depths. We can fire that nozzle system of nozzles at a point in time different from others at different levels. So that works out really great.
Yeah, I've seen that myself in systems where they've got an aeration grid and a big deep cone, and you're able to mix all the way down to the bottom of that cone, even though the aeration grid is up above it and like an activated or an aerated sludge application. Another question for you, Mark. This one was asked, I think, when we were going through one of my questions. It says, why do you cut off the applicability at 30 feet of depth? I think they might have just caught me on my terminology, the way the question was worded.
Yeah, it's a good question. Our experience, we've mixed tanks up to 30 feet in depth. Pretty uncommon to run into tanks requiring mixing at greater depths. That's just where our experience is at this point. Likely we could, because we're using high pressure air, we could possibly look at doing tanks that are greater at depth than that, but that's pretty standard in this industry.
I have another question here. The question is, it says, can I use an existing blower? I'm guessing that they're talking about a compressor.
Yeah, it could be. I'll address it both ways. So let's assume for a moment it is a diffused aeration compressor in an existing system, and yes, we would certainly take a look at that in the ability to interlace compressed gas mixing with fine bubble diffused aeration. So it is possible to utilize an existing blower system. However, oftentimes we need to really scrutinize the turn down capability of a fine bubble diffused aeration blower, for instance, to make sure that it would have the range that we would be looking for. Um, if they mean an existing compressor system, yeah, as I outlined on some of these, the Price River case study in particular, yes, we could probably utilize an existing compressor system. Again, we would give the functional requirements, how much clean, dry, refrigerated dry air we would be looking for. And yeah, we can certainly look at what a customer has.
Thanks. That actually leads us to another question. Someone had asked about using a dryer if that was necessary. If you
Yeah.
could just talk through that. If it says, have we ever used one?
Yeah, good question. So yes, we offer a variety of compressor systems. Most commonly, the a common off-the-shelf compressor is utilized that has an integrated refrigerated dryer system in there. Why are we trying to dry the air? Because we want to remove condensation that can cause moisture buildup in the system and problems with the valves functioning. So we want to have clean, dry air. Most commonly, we will utilize a compressor that has an integral dryer with it. However, we've utilized additional standalone refrigerated dryers, and we've also used desiccant type dryers. So yeah, there's a wide variety of tools available to us to provide that clean dry air that we're really looking for.
There's another question here. Can you talk about anything that needs to be considered when looking at retrofit opportunities?
Yeah, retrofit opportunities. Again, there's a myriad of things that we can run into. For instance, what's the tankage configuration? Are there any obstructions in the tank to avoid? We can certainly work around internal tankage, whether there's a wall there. I mean, you've seen from the way we lay out the headers and the piping, there's all kinds of flexibility that we have available to us. However, we want to look at what's the existing tankage condition. If we're going into a wet installation, is there material that probably should be removed before we go into an installation? other as we're carrying the pipe, for instance, across the site, where are we going to site the equipment and the interconnecting piping? Is this going to be buried above grade? Is there freezing concerns? All these kinds of things are things that our engineering teams review in close review so that we ensure a trouble-free system. It's a good question
Nice.
because we do a lot of our work is retrofits and expansions of existing facilities.
Perfect. I did notice that we are at about our 40-minute mark, and we had originally planned to give everybody a couple of minutes back of their time. So there are a couple outstanding questions. If I didn't get to getting your question out live, we'll be happy to send you a response via email. Again, remember that we will send out certificates of completion for all of you that attended live. And there is a short survey when you log out of the webinar. And if you wouldn't mind answering those few quick questions for us and give us some feedback, we would greatly appreciate it. But thank you, Mark, and thank you all of you for your time and energy, and have a wonderful rest of your day.
Thanks for your time.